Hello students, today we discuss a singular solution of ordinary differential equation of order 1 and degree higher. Uh, Before discussing singular solution, first we discuss what is envelope. The definition of an envelope is given by an envelope of a family of curve in the plane is a curve that is tangent to each member of the family at some point, and thus point of tangency together form the envelope. Means uh, when we're talking about an envelope, we find envelope for a given family of curve. Means we have some family of curve, and for that we are to find an envelope. An envelope will be a curve such that it will be a tangent. This curve means this envelope will be a tangent to each member of the family of given curve at some point, and these points construct envelope, and these point of tangency together form the envelope. So let's take, suppose we are given a family of straight line. This is a family of straight line we are given, and we are to find the envelope for these family of straight line. So this curve is an envelope for this family of straight line. Suppose this is the first straight line, and somewhere here the point of tangency, and for second line some here the point of tangency, and so on, one by one. For each member of this system of straight line we find a point of tangency, and those point construct a curve which is called envelope for this family of straight line. Similarly, we have some curve. Suppose this is this is a curve of a given family. This is second curve of given family, third curve of given family, and so on. And they are very close to each other. So this curve is envelope, as this envelope is a tangent to each curve at some point on each member of family. Or in another way, we can define an envelope. The envelope of a given family of curve is a curve such that at each point of it means at each point of envelope touches tangentially one of the curve of family. Means at every point of envelope, a curve of given family will touch. So in this way we define envelope. To calculate envelope, suppose we have a family of curve which is a function of x, y, c is equals to 0, where c is parameter. For different value of c we have different curves. So for a family of curve which is function of x, y, c is equals to 0, to obtain envelope for this curve, first we partially differentiate this equation with respect to c, that is f prime c, x, y, z, x, y and c. Now we equate this derivative also 0, and from these two equations, first given curve function of x, y and c is equals to 0, second f prime c, x, y, c is equals to 0. Eliminating c from this system of equation, the resultant curve will be envelope. So now we take the definition of singular solution. Singular solution is actually envelope. The equation of envelope of the family of curve given by general solution of differential equation. It means here we discuss the family of curve is a special kind. The family is nothing but a general solution of given differential equation. We have some differential equation, suppose function of x, y, p equals to 0, and its general solution, suppose phi x, y, c is equals to 0. Then we have a family of general solution for given differential equation which is phi x, y, c is equals to 0, and for this family the envelope is a singular solution. Now, such a solution does not contain any arbitrary constant and it doesn't a particular case of general solution. Obviously, the singular solution also satisfy given differential equation, but it is not a particular case of general solution. Also, it doesn't contain any arbitrary constant. Further, if suppose Exy is equals to 0 is an envelope or singular solution of given differential equation which is function of xy p is equals to 0, whose general solution is what phi xy c is equals to 0, then this envelope, a relation of xy represented by e of xy, e some function e of xy is equals to 0, is a vector of both p discriminant and c discriminant. It means to find envelope for given differential equation, first we have to calculate p discriminant and c discriminant. In both discriminant, this is a factor. Envelope is a factor in both discriminant. So, what is p discriminant? So, p discriminant relation represents the locus for each point of which fxyp is equals to 0 has equal values of p. It means p discriminant is what? P discriminant is also a locus of some points. Locus of points, and the speciality of those points are for each point of which for each those point given differential equation is equals to 0, fxyp is equals to 0 has equal value of p. It means for those point which lies on p discriminant, for every point of the point lies on p discriminant, given differential equation has equal value of p. And to obtain a p discriminant relation, we are to eliminate p from these two equations, which is given differential equation and partial derivative of given differential equation with respect to p equals to 0. From these two equations we eliminate p, and resultant relation between x and y will be a p discriminant relation. Similarly, c discriminant relation is what? It is also a locus of some points, and for each points the general solution, which is phi x y c is equals to 0, have equal values of c. For every point which lies on c discriminant relation, this relation phi x y c is equals to 0, which is general solution, gives equal value of c. And similarly, it can be obtained by the equation phi x y c is equals to 0 and del f by del c is equals to 0. Now we look some special factors known as extraneous loci. There are some special kind of locus which are known as node locus, cusp locus and take locus. So one by one we discuss. First, node locus is what? First we discuss what is a nodal point, and the locus of nodal point will be node locus. So a nodal point is a point on a curve. Means we have a family of curve, and on every curve there is some special point is known as nodal, but it has some special property. A nodal point is a point on a curve that is a double point. Means this point is a double point and has two direction of the curve given at the point. Means from at this point two different tangents can be drawn. It is a double point, and at this point two different tangents for this curve can be drawn. And a continuous curve made up of such points is called node locus. Means locus of such points is called as node locus. Now we discuss the property of a double point. Suppose fxyc is equals to 0 is a curve, then a double point is a point such that for that particular point fxyc is equals to 0 and So with this condition, two more conditions also satisfy. One is fx, it is partial derivative of with respect to x. Fx is equals to 0, and fy, this is partial derivative of given equation with respect to y. These both are 0 at that particular point. It means if these three conditions are satisfied, one given equation should be satisfied, and beside it these two, fx is equals to 0 and fy is equals to 0, these both are satisfied for that particular point, means that point is double point. Now we look cusp locus. So a cuspidal point is again a double point, but this is a different point than nodal point. Here the tangent will be unique. A single tangent can be drawn at that double point for given curve. But in node at the point nodal, two different tangent can be drawn. But here in the cuspidal point, a single tangent can be drawn at double point, and the locus of such points is called cusp locus. The third one is take locus. The take locus is a locus of points such that two separate solution curves are tangent at each point of locus. It means at the locus of such points that at every point two separate curves are tangent. Two separate solution curve will be tangent at each point of take locus. So take locus is a locus of those points such that at each point two separate solution curve will be tangent. Now how we trace from P discriminant and C discriminant that which factor is envelope and which factor is take locus or cusp locus or node locus. So the factor which appear in both, which present in both P discriminant as well as C discriminant will be envelope, but condition is that its power should be 1. It appears in P discriminant once only. Similarly, it appears in C discriminant once only. That will be envelope. And a factor which appear in P discriminant but does not appear in C discriminant, and it appears in P discriminant twice, it will be take locus. Whereas node locus does not appears in P discriminant but appears twice in C discriminant. And cusp locus is a factor which appears in P discriminant once and 3 times in C discriminant. So in this way we can trace out which factor is envelope and which factor is take locus or node locus or cusp locus. Envelope is always a solution of given differential equation, whereas take locus, node locus and cusp locus are not necessary that they are solution of given differential equation. In some case they might be solution of given differential equation. Now we solve some problem. Here we have a problem: obtain the complete and singular solution of the following equation. Also explain the geometrical significance of the irrelevant factor that are present themselves. So we have a problem, given equation 4xp square is equals to 3x minus a whole square. So first we find its complete solution. After that we find its singular solution or remaining factor, which one is take locus or node locus or cusp locus, or either they present or not. So first we will solve it for P, as we have already discussed to solve this equation, such equation for P or Y or X. So first we find the value of P, which is plus minus 3x minus a upon 2 root x. From here we separate x and y and integrate it. After integration we get general solution, which is given by y plus c whole square is equals to x minus whole square. Now to find singular solution, equation 2 shows complete solution. Now to find singular solution we are to calculate P discriminant or C discriminant. So we can calculate P discriminant with the help of given differential equation. So we differentiate given equation 1 partially with respect to p. So after differentiating we get 8xp is equals to 0. Now we'll use this equation in given equation. The given equation is 4xp square minus 3x minus a whole square is equals to 0. From equation 3 we have xp is equals to 0. So multiply this equation x, we get 4x square p square, and putting xp is equals to 0. So when we multiply this equation with x, here we get 4x square p square minus x 3x minus a whole square is equals to 0, and putting xp is equals to 0, it gives us minus x 3x minus a whole square is equals to 0, or x into 3x minus a whole square is equals to 0. This equation 4 shows p discriminant. Now to obtain c discriminant, we will differentiate this complete solution partially with respect to c. So after differentiating partially with respect to c, this equation we get twice y plus c is equals to 0, or c is equals to minus y, and putting this y c is equals to minus y in complete solution, we obtain x into x minus a whole square is equals to 0. Now this is c discriminant and this is p discriminant. Now we look here which factor appears in both and once only. That factor will be singular solution or envelope. Here 3x minus a appears twice. Here x minus a appears twice, but x appears in both p discriminant and c discriminant. Also it appears once only in both discriminant. That's why x is equals to 0 is envelope or singular solution. Whereas 3x minus a appears twice in p discriminant and doesn't appear in c discriminant. That's why 3x minus a is equals to 0 is take locus, whereas x minus a is equals to 0 is node locus, and in this case no cusp locus appear. So in this way, we after calculating p discriminant and c discriminant, we can decide which factor is envelope and what about other factors, take locus or cusp locus or node locus, either they appear or not. Now we have another problem. We are to find complete solution and singular solution for this problem, which is p cube minus 4x by p plus 8y square equals to 0. Here as x appear in degree 1, that's why we can solve it for x. So first we find its complete solution for using the method solvable for x. So x is equals to 2yp plus 1 by 4 p square y. The method of solvable for x is that differentiate this equation with respect to y and replace dx upon dy with respect to with 1 upon p, and hence we get a relation between y and p, and when we solve it we get a relation between c, y and p. So we obtain a relation p square is equals to cy, or p is equals to cy raised to power half. Now to obtain complete solution, we have to eliminate p from this solution and given problem. So putting the value of p from here in given problem, so we obtain cy raised to power 3 by 2 minus 4xy into cy raised to power half plus 8y square. Now we will simplify this equation and we obtained c raised to power half upon 2 c minus 4 by minus x is equals to minus y raised to power half. After simplifying we get y square is equals to c minus x whole square. This is complete solution for given problem. Now to obtain singular solution, we are to find p discriminant and c discriminant. To obtain p discriminant, we are to differentiate given equation, differential equation partially with respect to p. Hence we get 3p square minus 4xy is equals to 0. It gives us p square is equals to 4xy upon 3. Now putting this value of p in given differential equation, so given differential equation is 8y square is equals to 4xy minus p square into p. We rewrite or we rearrange given differential equation in this form. Now we will put the value of p in this equation, and simplifying it we get 27 y raised to power 4 minus 4x cube y cube is equals to 0. Or it can be written as y cube, taking y cube outside, y cube into 27y minus 4x cube is equals to 0. This is P discriminant. To obtain C discriminant, differentiate complete solution, which is y is equals to c minus x whole square. This is complete solution, y square is equals to c minus x whole square. We will differentiate it with respect to c. So we get c minus x and 3c minus x is equals to 0. From here we can obtain the value of c. C is either x or c is either x by 3. When c is equals to x, from complete solution we get y is equals to 0. But if c is equals to x by 3, from complete solution we have y is equals to x by 3 into 4 by 9x square, or 27y minus 4x cube is equals to 0. So complete C discriminant can be given by y into 27y minus 4x cube is equals to 0. So C discriminant for complete solution will be y into 27y minus 4x cube equals to 0. Now we have P discriminant and C discriminant. Here 27y minus 4x cube is equals to 0 appear in C discriminant once only, and also 27y minus 4x cube appears in P discriminant once only. It means 27y minus 4x cube should be an singular solution. Also the other factor is y cube in P discriminant, whereas y is another factor in C discriminant. So y cube in P discriminant can be written as y into y square. We can separate y cube as y and y square. So factor y appears once in P discriminant as well as y appears once in C discriminant. So y is equals to 0 is also another singular solution for given problem. And whereas the remaining factor, which is y square, is take locus. And no node locus and locus locus appears in this problem. So y is equals to 0 and 27y minus 4x cube. These both are singular solution for this problem. So in this way we are to calculate singular solution or some extra non-linear loci for given problem. That's all.